Good morning students. So today we are starting our next point, which is IP addressing under the unit of ISO OSI model. So let's start with the introduction of classical IP addressing. IP address is an addressing having information about how to reach a specific host. When you want to send a data from sender to receiver side, with that we require a host or a destination IP address to send a data properly. Under that, IP address is a 32-bit unique address having an address space of 2 raised to 32 because it has a binary notation. With that, the address space will be calculated as 2 raised to 32 because it is a 32 bit. So generally two notations are used for IP addresses. First is dotted decimal notation, and second is hexadecimal notation. In the dotted decimal notation, the binary address space is converted into decimal notation. The figure is shows you that binary conversion of decimal conversion of binary notation. Then the second notation shows you the hexadecimal conversion of binary language or binary address space. So these are the two notations. Those are used in the IP addresses. If you don't understand how to calculate the decimal notation and hexadecimal, you just have to remember that the unit place, the 10th place, the 100th place, the 1000th place is multiplied with a decimal. It has base 10. So 10 raised to 0, 10 raised to 1, 10 raised to 2, equally the unit 10th 100 place will be multiplied and calculated the actual address. Same as the hexadecimal, where we calculate it with the base of 16. So next, that classful addressing has actually 5 subclasses. Those are class A, class B, class C, class D and class E. Under that, D and E classes are reserved for multicast and experimental purpose. So these D and E is specifically reserved for multicast and experimental purpose. So A, B, C be used for actual IP addressing. So basically we will discuss about the IPv4 address. IP in the network, the addressing is done with the help of Internet Protocol version 4. But nowadays they use IPv6, which is nothing but the Internet Protocol version 6. Under that, two parts of IPv4 is used in the network. First is network ID and second is host ID. This can be explained very nicely with the help of diagram. In this diagram, we have 5 classes and the bytes can be divided into 4 parts. So each byte contains a 8 bit. You know that. So 8 for the 32. So 32 bit calculation is done in this diagram. Class A has net ID only 1 byte and all other IDs are host IDs. In the class B, 2 bytes are used for net IDs. Under the similarly, class C has 3 bytes for net ID and 1 byte for host ID. Like that, the conversion is done and the division is made for 32 bit of IP address, and C and D are reserved for the multiclass and the experimental purpose. Okay, so I hope you understand this diagram. This is very important diagram to understand how the classes are classified into 32 bit. So let's have briefly discuss about the classes. So class A, as the figure shows you, class A's first byte is reserved for the 0 octet. First octet or first byte is reserved for 0. And other host IDs are for 22 bits, 24 bits, and 7 bits are reserved for the network. So these are the classification of class A. Actual class A has network ID 8 bit long and host ID 24 bit long. But the first bit can used for the were set as a 0. Okay, so this actual diagram is shows you all these things. Okay, next thing that you have to remember in this, that address space of the for the network is in the class A is 2 raised to 7, and the address space for the host in the host ID in the class A is 2 raised to 24. Oh, so this is nothing but the class A. Next is class B. The same thing the diagram shows you. IP address belongs to the class B are assigned to the network that ranges from the medium size to largest network. So in that the network ID is 14 bit and the host ID is 16 bit. But the first octet of IP address of class B is always set to the 10. After that 10, 14 bit of network and host of 16 bit is adjusted. This is nothing but the B class. And address space as usual 2 raised to 14 for the network address and the 2 raised to 16 for the host address. The range part, that from this range to this range A class and from this range to this range is B class, that we will be discussed in the briefly in the table. So class C, the diagram shows you that the first octet or a byte of a IP address of class C are always be set to the 110. And the network bit is 24 bit and host bit is 8 bit. Okay, so address space will be for network 2 raised to 21 and for host 2 raised to 8. So class D and class E is reserved for the multicasting. Class D is reserved for the multicasting and the class E is reserved for the experimental and research purpose. These are the range. These classes or first octet of D is always stated as 1110, and for E classes it is 1111, which is 4 ones. Example of class E and class D will be explained very thoroughly, that how the bit is calculated. Okay, so let's have briefly discussion about the summary of classful addressing. Classful addressing has subclasses of 5. Those are class A, class B, class C, class D and class E. The first leading bit is adjusted for the A class is 0, B class is 10, C class is 110, D class is 1110 and E class is 1111. So second thing is net ID. Net ID is depend on the how many bits of leading bits used in the class. Here in the class A, no actual leading bit is used, only 0 is placed in the leading bit. So because of that net ID is 8. B class 16, C class 24. D and E class, no actually net ID and host ID is used. Only the start address and end address is used. So as the net ID is using a 7 bit, because first leading bit is 0 and remaining 7 bits are used, so the number of networks are 2 raised to 7. The same thing for the B class, that the leading bits used in the class B is 2, and the remaining are 6 bits. So 2 raised to 14, because it's actually 32-bit calculation. So 2 raised to 14, then 2 raised to 21, and calculated in the network ID. The address per network is 2 raised to 24, 2 raised to 16, and 2 raised to 8. This all calculation is written in the classes where we discussed briefly. So in this summary table, the summarized numbers are written. Next, that you have to remember is start address and end address. When class A is started with the 0 and end it with the 127. When the class B is started 128 and ended with the 191. Class C starts with a 192 and ends with a 223. Class D is start with a 224, ends with a 239, and Class E is start with a 240 and ends with a 255. So under the 255 address, this type of classification is done for the classful addressing. So this was the our today's lecture. So let's now conclude today's lecture, that we learned today the address pool classes or classful addressing. In the classful addressing, we learned about what is IP address and why we used IP address. Next thing that we learned is IP address notation are two. First is dotted decimal notation and second is hexadecimal notation. Third thing that we learned is classful addressing subclasses are 5. Those are class A, class B, class C, class D. Actual classes are the IP address of 32 bits. So it will be divided into a net ID and host ID. In the class A, net ID is 1 byte. Class B, net ID is 2 byte. Class C, net ID is 3 byte. And class D and class E are reserved for the multiclassing and experimental purpose. Class A has 0 bit to set and 7 bit network and 24 bit host. Class B is 10 set and 14 bit and 16 bit is host. Class C set 110, 21 bit network and 8 bit host. Class D is 1110 set and 28 bit for the host. No network ID is used in the C and D classes, and because they not used for the network purpose. Okay, and this is our summary table. So I hope you understand today's lecture. If you have any queries, please free to ask me.